The savanna of Africa, home to countless animals, each shaped by survival. But one stands apart, a predator that has placed all of its evolutionary adaptations on a single strategy. The cheetah holds the title of the fastest land animal on Earth, capable of reaching speeds over 110 kilometers per hour, accelerating from 0 to nearly 97 kilometers per hour in under 3 seconds. But raw speed alone is not enough. To survive, this predator must combine velocity with precision, maneuverability, and timing. Every part of its body works together like a finely tuned racing machine. Its skeleton is light and flexible. The spine acts like a spring. During a sprint, it flexes and extends dramatically, increasing stride length by up to 7 meters. This spring-like motion works with rapid limb cycling, producing stride frequencies of 3.5 to 4 strides per second. The limbs themselves are long and lean, with elongated radius and tibia bones, allowing rapid, repetitive motion without adding unnecessary weight. Muscles are dominated by fast twitch fibers, optimized for explosive bursts of acceleration rather than endurance. Each hind limb can generate up to 4,000 newtons of force per stride, propelling the cheetah forward at incredible speed. Its claws are semi-retractable and firm, acting like cleats to provide traction during sharp turns. Foot pads are hard, biting into the ground with every step, reducing slippage even on uneven terrain. At top speed, more than half of each stride is airborne, minimizing ground contact and maximizing velocity. At extreme speed, the cheetah moves faster than it can consciously react. Each stride is coordinated by reflexes, rather than by thought-driven action. Humans running at top speed can adjust their stride consciously, according to their vision, but cheetahs must rely on these pre-programmed patterns to maintain stability. Even a tiny misstep, a paw slightly out of place, or the body leaning incorrectly, can destabilize the sprint and abruptly end the chase. But speed is useless without control. The cheetah's long, heavy tail functions as a dynamic counterbalance, stabilizing its body during rapid changes of direction. It can handle lateral forces up to 1.5 times its body weight, allowing it to chase agile prey across unpredictable terrain. These bursts of extreme activity come at a physiological cost. The cheetah's heart rate can exceed 250 beats per minute during a sprint, and respiration spikes to deliver oxygen to muscles. Body temperature rises quickly, and cooling is critical. A chase longer than 20 to 30 seconds risks overheating. Every sprint is a high-stakes gamble. Vision is equally specialized. Forward-facing eyes provide precise depth perception, while dark tear marks under the eyes reduce glare from the sun. At 100 kilometers per hour, most animals lose visual stability. The cheetah doesn't. Its head remains unusually stable during a sprint, allowing the eyes to stay locked on a moving target. Even subtle changes in muscle tension or head angle are detected instantly, enabling unrivaled agility. Before sprinting, cheetahs often stalk or crouch, conserving energy and reducing distance to the prey. They select fast but unpredictable targets, gazelles and impalas that can reach 50 to 90 kilometers per hour themselves. Success is never guaranteed. Only about 40 to 50% of hunts succeed, reflecting how energy-intensive and high-risk these chases are. A failed hunt forces a prolonged recovery. For 20 to 30 minutes, the cheetah must clear lactate from its muscles, lower its core temperature, and repay the oxygen deficit created by the intense anaerobic effort of the sprint. Furthermore, cheetahs are lighter and more fragile than other large predators. So, after a successful chase, they sometimes have to abandon their prey, as they can't defend themselves against other hunters in this exhausted state. Cheetah cubs are born tiny and helpless, weighing only 250 to 425 grams. During their first weeks, they follow their mother closely, practicing short bursts of speed and crouching movements that build the coordination and reflexes essential for hunting later in life. In the context of the animal kingdom, the cheetah is unmatched on land. No mammal combines raw speed, coordination, and precision in the way it does. For humans, even the fastest sprinters like Usain Bolt reach only about 44 kilometers per hour, less than half the speed of a cheetah. This overwhelming advantage is studied by engineers, and the research is already being applied. Robotics labs use cheetah-inspired models to develop fast, four-legged machines for search, inspection, and movement across rough terrain, where stability and rapid acceleration matter more than endurance. The cheetah is not nature showing off. It is nature making choices under pressure. Efficiency over endurance, speed over strength, precision over power. Every bone, every tendon, every organ is optimized for a single function. When it works, the cheetah is unmatched. When it fails, there is no backup. Evolution has produced speed incarnate, a fleeting window of dominance, a predator built for the extreme. This is extreme by design, a creature that embodies what happens when evolution commits fully to a single purpose. A predator of speed, a machine of motion, and a reminder of how extreme life can become, under the pressures of survival.